Hello, everybody. Welcome in today's call from Frogeex again. Here we talk a lot about sustainability, sustainable building, living, and all sorts of stuff that is connected to nature. Today, it's my absolute pleasure and honor to welcome two exceptional people that I had the pleasure to meet on the Bamboo Expo 2023. Reference to Iraklis, as always. I'm sure we're going to hear more about that too. Mr. Johan Gielis, inventor, scientist, a legend in many ways. When we talk about bamboo research, we talk about high technology. And today the topic is nature's geometry. So that's where Johan is going to kind of take us on a journey on his research. And I believe it's going to be also a little bit of an interesting exchange on how can we utilize nature's geometry also in building and architecture. And that's my bridge to Mauricio Cardenas, today here with us from the Cardenas studio. Now, those of you that follow us for some time and kind of are living in the world of sustainable materials and sustainable architecture, green buildings, also for sure know Mauricio for his work. He has been also titled by the press as the bamboo architect. So that already states a little bit, the similarities that we have over here. Bamboo is certainly one of the things or one of the interests that we share. So those of you that would like to maybe research a little bit on his background, for sure, you will come across one of the exceptional works, the I Pavilion, which was used for the expo in China, and is a building that was coming from the interest of of the International Rattan and Bamboo Organization to kind of promote more the possibilities and the capabilities of this material coming from the head of Mauricio. So a warm welcome to both of you, gentlemen.
Thanks for inviting us.
Thank you so much. Really interesting.
Now, that was a very humble hello to the community that we have in Frogeex. As mentioned before, we talk all about sustainability, connected to nature, how to be connected to nature, how to leverage the elements. And one like overreaching topic that we have is the fascination by nature. How do we observe? How do we utilize? How can we connect these elements? That was like the first person that came into my mind to invite for this topic, and where I see that we share some common ground in this was Johan. Johan, I had the great pleasure to receive your book. Everybody can see it on the camera, Inventing the Circle, which I got as a gift at the Bamboo Conference 2023. And thank you so much for that, Johan. It opened my horizon to the way you see nature and where you see the connections. How do you read these patterns? So as the godfather of the super formula concept and inventor of this idea, can you maybe tell us more and our audience, why is it important and what is it actually?
So for this to explain, I will require some imaginations from the audience. You can close your eyes or you can, but let's say you have a circle inside a square, and you inflate the circle in the square, then it becomes more like a square with rounded corners. Huh? And so you can inflate it further and further until the balloon fills the complete square. Yeah, and that's if you go back to the original equation of the square, which is a x squared plus y squared equals r squared, the Pythagorean theorem, then any of these shapes has their own exponent. Instead of an exponent 2 for the circle, use an exponent 2.3 or 5.7, and the higher the exponent, the more it approaches the square. You can do the same from an ellipse and then inflate it into a rectangle. So, and I came across this because my background is bamboo, and remarkably, there's a genus of bamboos that have square stems. Almost square stems. They're the kimono bamboos. It's quite a large genus with 21 species approximately in southwest of China. And they have to withstand snow and storms and so on. And they shoot only very late in the season. So they don't have time to lignify. So they have to find other solutions. And having a square stem, and there are many examples of square stems in in the plant kingdom. That brought me as a start. So we can also inflate a sphere into a cube and get the same, then you're adding some dimensions. But what was for me very interesting is that this is also an optimization principle, because it's the first time I read about this equation was on Sergelstorg, which is a market in Stockholm, and it has to optimize the area inside for a shopping mall and also the traffic going around it. So an ellipse was fine for the traffic, and a rectangle was fine for the optimizing the inside mall. But the architects tried to have arcs and circles and lines to do that. And then Piet Hein came along and said, well, there's a super ellipse. Do you know this? It's one curve. It's a unity. And that has been, we find it now in square bamboos, in square stems. For example, one example which I also use, if you look at teak trees and teak branches, they always start square and become round later only. There's many examples like the cells of bamboo and anatomy of wood. They're all squares. It's stacking optimally. So if you stack oranges, you have balls. But if you stack cells, you have a lot of interface between the cells for exchange of nutrients and so on, and water. So now imagine going one step further. Now we have observed this in so many plants. Now imagine that you have to do that, the same principle for a starfish. Just imagine that instead of having 4 anchor points like a circle and a square, you make 5 anchor points, and then you can transform your circle or your square, even in your mind, into a starfish or a triangle or a flower. Now you can do that, and actually what the super formula does is the exact, let's say, mathematical equation to do this. Now, that's one. So we see it everywhere in plants, and it has been used in in architecture, but it's also very well known in urban design. And I want to point it out because mostly we think about circles and then reaching out. So if you're standing in the middle of Paris, let's say, and then you can drive for 58 euros with the taxi in each direction, more or less, and you will end up at a circle. But if you do that in New York, in Manhattan, you have a square stamps. So if you want to go 10 blocks, you can go 10 blocks to the north, 10 blocks to the south, east, or west. Or you can take 8 blocks and then 2 to the east or 2 to the west. Or you can take 5 blocks north and then 5 blocks east to the west. So you will be ending up, your unit circle of 50 euros or $50 in that case would be a square. So there are, even in urban planning, we have to look beyond the Pythagorean theorem and the Euclidean distances, and then everything becomes more clear and more logical. So that's basically what I can say about this as a general principle. So, and then there was this, how to use this in terms of sustainability and so on. I will only say this. Before we have thought of divisions. A square and a circle were very different. A circle is more feminine, and for some reason a square is more masculine. I don't know where that came from, but now we have a continuum between these shapes. So they can morph into one another. And instead of divide things, we unite things. And I would like to quote Barbara McClintock, which was a Nobel Prize winner in medicine for fantastic work in plants. She said, basically, everything is one. There's no way in which you can draw a line between things. And what we normally do is to make these subdivisions, but they are not real. So our educational system is full of subdivisions that are pretty artificial, that should not be there. So that's the in general. So you have a shape description, but you also have this idea of unifying things in nature and so on, as a continuum. So my short answer to this.
Well, I mean, amazing, because as mentioned, when going through your book and kind of also reading through the examples, the observations, the different, as you said, the origins of these shapes and how they merge, how they are connected. It was a little bit like eye-opening, because you see that so many shapes come from one form or have origins in the same form. So very, very interesting thought process, I would say, in this. And it's also a new invention. And I really appreciate also the practicality that you pulled into the book, also in the example that you mentioned with the planning, with the urban planning elements. And I think that brings us also closer to Mauricio in his area of competence, architecture, planning, design. How do you work with either the super formula, or we talk a lot about mimicking what nature does, how nature is dealing with things. So with biomimicry, do you kind of have certain inspiration points for you that are continuously with you on the journey, also designing such projects as maybe the iPavilion, or how do you implement biomimicry in your designs?
Yes, absolutely. It's a very important inspiration. Nature. My feeling is that, of course, Johan sees it from a mathematical point of view, because he understands this language, which for me it's easier to understand it from geometrical point of view and proportional point of view. But at the end, the answers, or the solutions can come to a common place. For example, I'm very fond of geometry, and the geometry usually, the inspiration comes from nature. Once upon a time, I was looking at other architects, and it's part of the growth, of the professional growth, like looking at architects as an example, or a master, etc. But slowly I've been looking less humans and more nature, because you can find things that are so incredible and so apparently simple, but so at the same time so complex, like the geometry of a flower, a geometry of like the Hoya Bella flower, which
Fantastic.
it's fantastic. It's a cupola. It's a perfect, and it changed, as you were saying. Like, as an architect, probably I see geometries and forms in a static manner, while Johan's description is more fascinating because its movement is changing from a circle to a square. Which sometimes we see them as opposites, but they can be one, right? And in fact, it's one of the most fascinating challenges that was happening during history, was squaring the circle, right? As a
Yeah.
mathematical solution done by artists and geniuses, and
Well,
all
same
through the,
Elizabeth anyway.
all through the history until today. Um, so we definitely look at this. We look at toroids. For me, toroid is a very interesting geometry, and a toroid is basically like the wheel of a bicycle, the right, and it's a perfect geometry, for example, for making for making standardization, for example. Like, Johan mentioned the word optimization, which is
Yeah.
exactly, it's perfect. You can optimize, like you see many buildings which are, they can be better optimized. It's called, in construction, let's say, it's called value engineering, right? And then that can be done through mathematics, through geometry, uh, uh, making that even the form of the building, it's still looking organic, or looking kind of undefinable, but it is not really, because it's made in order to match also the budget. It's not to make it so expensive. Many pieces are similar, like our cells. That so with our cell, with the cells, or with the honeycomb, right?
Yeah.
uh, you can make so many different forms, but using one let's say basic geometry. So absolutely, in nature you can see so many examples, but it's so complex because nature changes. We think plants don't move, but they move. All the leaves of the trees can actually catch the sun, There's not no one gives a shadow to the other, and it's so. For our eyes, it's difficult, or at least my eyes is still difficult to understand. So I'm really fascinated. I'm looking that more and more, and Johan's book is another really amazing eye opener for understanding this better and seeing it from his point of view. Yeah.
I totally resonate with you. Sorry, Johan.
If I may add, I'm glad you mentioned Hoya carnosa, because this belongs to a group of flowers, which is one of my favorite group of flowers. And they're absolutely fantastically beautiful and geometrical. But many genera and species from that group stink like urine and so on. And why? Because they grow in deserts or semi-deserts, and they have to attract pollinators from very far. So by smell like feces and so on, and that's how they attract pollinators. So nature is so inventive, and we only barely scratch the surface for this. I also want to add to the optimization and cost and so on. If we look at tree rings, for example, of softwoods, then they are also supercircular. So a circle has an exponent of 2 in the equation, but in super tree rings, it has an exponent of, say, 2.05 one year, and the next year 2.1, and so on. What is important there is that tree rings are a multi-objective optimization phenomenon. So they built upon what was already there, the tree ring of last year. They include all the factors of this year: drought, rain, temperature, diseases, and so on. And they prepare for the next year. So tree rings in itself are very fantastic, but a multi-objective optimization problem in a superelliptic way, which means very simple geometrically and mathematically. And these are the things we just start to discover. And multi-objective optimization, whether you are an architect and you have to take into account the budget and the wishes and so on. But in nature, it's the same. Multi-objective, not optimizing only one thing, but simultaneously or in parallel, 20 things that you have to take into account.
Amazing.
Totally fascinating. I mean, one question that we did not have, like, on the list of the topics to discuss, but certainly, I mean, would there be any priorities that you would say, for both of you, a question and maybe to reflect on, what do you optimize first on? I mean, do you go, I mean, budget is usually what we have for architecture, but, you know, how can we combine these two views, these two worlds, leveraging what science is coming across with this wonderful new information that we are just learning to really apply? And back to the question, would there be any priority list, what to optimize on, if there is something like this? Or
it's a there's so many things that have to be put together, right? And I think already Johan mentioned many. The fact that how nature prepares, like the plant in the desert has to attract, right? So it finds a solution to survive, no? So survival, and we are also in the moment. We are also, in fact, you see, with humans, we are always creating crisis to then find a solution. I don't know. It's something that we see of many cultures that have been lost, and we continue to find archaeological pieces all around of amazing cultures, and we ask ourselves, how come they ended up? And we are now in a moment of history which sounds like somewhere we're getting somewhere dangerous, right? So and it's now when we're going to have to find solutions. We have to find the best which is economical, not only in terms of money, but in terms of energy. Which energy, money, we can say money is energy too. I mean, so it's in terms of energy. We have to make buildings. It's not possible that still buildings need so much electricity, so much energy. Probably buildings should start looking at nature and become self-sufficient. Also in terms of garbage, right? All of the garbage we produce. But you see, we're making photovoltaic panels, electric cars, and you see a tree, and it's the highest tech ever, or a bamboo plant. It's so amazing. It just captures captures water and keeps it, but not only for himself, but for the community, right?
Yeah.
And it's flexible, it's slim. It's so I think the solutions are there. It's just that we are used to look at catalogs and used to buy products instead of really getting deeper into the problem. It's a mind changer, and I think books like Johan books and points of view like his research should arrive to the industry to the people that are doing the same business since so many years. You get a skyscraper from the first skyscraper in Chicago in the 1950s, maybe even in 1950s, and you compare it to the latest skyscraper built today in the world, there's not much difference. And the difference is not it's just a geometry. Maybe it looks more beautiful, more whatever beautiful, but beautiful is it's an opinion in a way. It's relative, right? So we really have to change the way of making things, and nature is an amazing example for doing that, and it's so fascinating, can enrich our work so much. Yeah.
If I may add to this, if you look at a cactus, for example, it's also something very fantastic, because if it absorbs water, if it rains, it swells, huh? And then it uses the water. But going back to super formula, you can make a section of every piece of the cactus, will all be different, but you can assign a correct set of numbers to that with the super formula. And that's important because in engineering and architecture, you use engineering formulas to compute torsion and bending. But now we can compute area or torsion or bending for every section of, let's say, rhubarb or petiole. So there's more possibilities. And I work now in antenna company, so we are developing antennas with our algorithms based on the super formula. And what is interesting also, not in CAD in general, is normally in CAD programs or in drawing programs, you use from a selection, you start from a circle or a square or a cylinder, and then you combine things and you compute things. But in our antenna technology, the shape is not given. It's part of the optimization algorithm. So you have to fit on 6 or 10 antennas in one device. It has to conform to the regulations. It has to conform to the height of the device and so on, multi-objective. And then what comes out is typically a shape of an antenna that was not there before. So optimizing a shape. You also have in design topology optimization, taking parts away to save on materials and so on. Also there you could use this. Not only super formula, but there are many developments in topology optimization and materials and so on that will come into different parts also in architecture. But maybe we can touch on this later. So
for sure, I hope enough time for this exciting topic. And one thing that you mentioned, and it's also connected from both of you, what you said in this conversation. Johan, you in the beginning mentioned that also, especially the statement around unity, around interconnectedness, around coming from many things coming from one origin. So I found this very interesting. And also you then mentioned, Mauricio, I mean, how does it then come back to the industry, such insights, such, kind of deeper level of knowledge, of understanding how things work, how system can work, how we can optimize that. How does this come back to the industry doing the projects in reality? And my question to both of you is, what is your perspective on kind of lessons that we may learn from nature for your individual industries? I mean, Johan, you are in high tech, in science, in research, so a maybe different perspective, Mauricio, for you, for building, construction, architecture, design. What are your perspectives on that? What are the lessons we can take, like maybe universal truths or principles that you kind of observe during your work, also with nature? And connected to that, I have a second question, but let's maybe start with this one.
Shall I start? I'll try to give a short answers to this. So basically in architecture and all this, one of the major things we have learned over the past centuries is using forces to calculate the forces at them. For example, Gaudi hang all his designs upside down just to make sure that the forces came out right. But I would like to stress that there's more and more insights from science, new materials, and so on. And I would like to mention metamaterials. Metamaterials were invented, let's say, theorized in the 1950s, 1960s, and they were only built in the 2001 for the first. And if you look into the water and you see a fish, you see it like this. Yeah? But in metamaterials, you have negative coefficient, and you can look behind the corner. So with metamaterials, you can make things invisible. So, for example, if you apply this kind of structures in seismic areas, you can divert all the seismic waves from the building away. And so there are also auxetic materials where you have a negative Poisson ratio. Normally, if you stretch something, it gets longer and a bit thinner in a way. Cork has a zero thing. If you push it down, it does not broaden. But auxetic materials can stretch in all directions and get from a plane to a curved thing. So these are all kinds of insights from and interestingly, the auxetic materials and metamaterials were always considered to be man-made. But in our studies of diatoms, for example, which produce small algae, which produce this glass, these cages of diatoms are glass, but they can filter out UV light, they can orient themselves, they can swim. It's unbelievable. We're just learning this now. And for example, the diatom is a metamaterial from nature's origin. So we're just getting to understand this all now.
Incredible.
There's so much to be learned and so much to be integrated in all fields in the 20th century. So the 20th century was basically the century of physics and chemistry, and the 21st century will be the century of biology and complex systems.
It's very exciting. In fact, the Atome, it's incredible. We applied it. I applied it in my thesis project for graduation from Milan Polytechnic. I was inspired in diatomy, and did the project was based on the structural, but I was looking at it from the geometrical point of view, the optimization of the geometry, but I never saw it from the point of view you just mentioned, which is much more complex. Is going further away, right? So basically, is going going further than geometry and then optimization, but getting into the realm of how do you say, structures that can be self-supported, that can be from 360 points of view, right? Like an organism. Yeah.
All these things, evolution. Yeah, sorry.
Yeah.
Biology and evolution, that's fantastic. And so everything in nature is in some way intelligent by itself. So
exactly.
Or in biomimicry, the way termites build their mounds and so on, and organize a fantastic system of temperature control. It's beyond our imagination until we study it.
In fact, we probably this will help also humans to understand that we are not the best of nature. That we
yes,
are.
Yes, indeed. Correct, completely correct. So.
Well, and in this perspective, and thank you so much for sharing your observations, your learnings, your takeaways from the experience in your field. Now we have all these, young people that need to prepare to handle these challenges. They're studying architecture, they're in science. How would you prepare the next generation to kind of absorb, leverage this information that we have? What do you think is maybe missing? I mean, what's your take on that one? Maybe Mauricio, you can start first then.
Okay. So I think that also part of the previous century, um, as mentioned by Johan, we got specialized. So there is engineers, there's architects, and architects were interior architects, industrial designers, urban design. Everything is specialized in imagine if we talk about medicine. So there's doctors that are experts in hearts, but they don't know much about other parts of the body because they got so specialized. And so probably today it's a matter of getting it's okay to get specialized, but to work in teams, or to become less specialized and look things from a broader point of view. Because the specialization has taken us into the crisis, into the problems we are having today. So what I suggest is that if you are getting very specialized, don't close your eyes and look that you're specialized, but you're just one of the orchestra musicians. Without the other musicians, you cannot make a beautiful
Yeah.
a beautiful orchestra music concert.
Yeah, I would just applaud your vision on this, because the way I always explain it to people is that science, for example, it's like a river, and it ends up in a delta, and these deltas are all small rivulets, and in each they have their own conferences and their own journals, and they all think they're on top of the world, but we have to get back upstream to see what this delta is about, and to understand where the water comes from that feeds each of these specializations.
Lovely.
So
And now, just also maybe because you brought this idea a little bit up, and I believe it's going to be also with the timing one of our last questions, if not the last one. Let's see how we go about the time. In terms of resilience, adaptability, you mentioned it also yourself, Mauricio and Johan. You are, deep in the topic of, the developments of the Earth system and the phases and everything. So we need to get ready for some new challenges, need to come up with new solutions. What do you think? How can we apply this nature's geometry, learnings from biomimicry to create more resilience and either the structures that we have, technological solutions or new applications?
yeah,
Whoever would like to start first.
you choose, Jana.
So Johan, it would be now your turn then.
Okay, thank you. So yeah, well, we have to understand first of all that nature is very resilient. Huh? In general, we assume that we are destroying nature and all this and that, but nature is very resilient. For example, we have an increase of CO2, but CO2 is plant nutrition, and as a consequence of increasing CO2, the number of stomata on a leaf decreases. So 150 years ago, there were more stomata on a leaf than there are now, which means that they can do with less water. So it's a multi-objective optimization problem, and nature is adapting itself to changing conditions. We always underestimate this. So we need to understand resilience, and then we need to also define what is sustainability. So what do we want to sustain? We want to sustain local communities or the whole planet. I think the first would be a more realistic choice to do, in which architecture plays an important role. So, but what I think in sustaining and let's say is very important that we understand that if we start to understand nature better, we will see and understand that nature is something about abundance, not about restricted stuff. And once we learn abundanism, not making misuse of it, but understanding that nature has a lot to give, more than we understand, and that is through scientific and technological innovations, then we have to change our perspective. So, and I'm pretty furious at some of the people that wrote the first reports of the Club of Rome on Dennis Meadows and so on. They want to reduce the population to 1 billion people at most. But from my perspective, we should be proud as a human race, or whatever you call it, that we were able to grow to 8 million, and it will top off at 9 billion, sorry. And we were able to feed most of them, or we were able to house most of them. Let's be proud, and let's try to use that as in a positive way.
I agree completely. Yeah, that's very interesting, and also being a little bit more open-minded as well. We see that organisms like ourselves, our skin is not the same that it was a month ago or even years ago. So being able also to not pretend to make buildings that would last for forever. Some buildings should last forever. Thankfully, they were built to last forever, like the pyramids, for example. But there are some buildings that probably don't need to, in which can be housing, for example, right? Some kind of, so making housings that can be uh, taken care of more than demolished and rebuilt, but making architecture that can be taken care of instead of trying to make, because now we see that we're finding ourselves with buildings, and we see there's a lot, and you can see it around Italy and many other places in Europe, as well as in Asia, that buildings made by the famous architects, etc., they're already looking old. They're already needing to be, but they were not designed to be taken care of. They were designed, so they're gonna be so expensive to take care of. So making it in a way that it's not expensive to be taken care of, like it's making it parts that can be replaced. Thinking as buildings is probably how we design cars. That cars or electrodomestics that can parts can be changed and can be repaired. But many buildings are just starting to fall apart because of, especially buildings from 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 uh, building with concrete, etc., are having several problems. But you see, looking back into nature, I read some recently some discoveries, some analysis from an American university, which I don't remember exactly, but they discovered that the Romans, the concrete done by the Romans,
Indeed.
right, and
Indeed.
that's why the old the very old concrete buildings are still uh, doing very well today
Yeah.
because the mixture, they understood very well how, and they understood it from nature, how to make this mix of materials that will repair itself in a way, right?
Mhm.
I think applying this to the contemporary, to the futuristic, can be very interesting solutions.
Mhm. If I can add to this, from a historical perspective, we have so much to learn. And you mentioned that before, Mauricio, and you mentioned now the Roman concrete. But I once saw a documentary where Rome was in the first century or before. They were always susceptible to floods and then water. So they built a kind of reservoir, a big reservoir around Rome. No? Let's say in the mountains, so they can keep control of the water, the runoff water, and keep control through aqueducts. But actually, I saw the same in Sri Lanka, a completely different thing. They built one in the first century. They built a complete system of water control over square kilometers by some kings there. So these ancient learnings are so important also. So we have to learn from nature. We are opening doors, but let's also look at history. So,
Absolutely.
for example, with lidar technology, you can now look through the forest.
Right.
You can really see the old in Guatemala, for example. They're unearthing completely new buildings and
Yes,
cities
found,
that
yeah,
were built.
amazing.
It's absolutely amazing. So much to be learned, and maybe we'll finally learn where the from Easter Island stuff came from. We don't.
Yeah, I would love to.
So it's to look at in so many possible directions as possible: nature, history, future. Look to humans. What can we? So
I
Look
agree.
what we have done and what we can do. Without being too proud of us as a species, and wise enough to show respect and value the foundation which we have.
mm,
That is what we always kind of keep as a motto now. Um, Before we close the call, maybe there are some events, some opportunities to meet you in person, to get to know you better. Maybe there are some opportunities where you have maybe a keynote or something. Would you like to share with us and with the audience where people can meet you next? Just besides LinkedIn, and we're gonna drop your profiles there.
Mauricio, please.
The lectures I'm going to give in the next couple of months. They are not yet 100% confirmed, but I'll publish when they will be. One probably will be in Switzerland. When
yes.
yeah, when it's confirmed, I will post in Instagram and as well as LinkedIn and everywhere is possible in order to hopefully meet new people and online or even better in person. Yeah, like we did, like we met in
Yeah.
last June in Dortmund in Germany, thanks to the Bamboo Expo, European Bamboo Expo. Yeah.
So wonderful. So we're gonna follow that. When there are dates out there, wonderful to hear about. Now, Johan, you mentioned the Symmetry Festival. Maybe you can tell our viewers
There's a
and listeners
Symmetry
more about
Festival in Pisa, end of July. But from my perspective, I'm not a real user of, let's say, social stuff. But all my presentations are available on ResearchGate under my page. So
Wonderful.
there's presentations on different topics. I have some papers on Medium, some 10 essays on Medium, which are very readable, linking out to toroidal systems that you mentioned, linking out to the heart and the circulatory system, mathematically shown to be one system only, relating to the inequality of leaves on trees, to the inequality of income in the world, and so on. So there are so many connections to be. Anyway, this is on my ResearchGate page, but I would also like to express my thanks to you, Jana, because you bring together two people who hardly met at Bamboo Expo from completely different points of view. You made some questions before so we could prepare, and it turned out to be a fantastic event, a meeting today. And Mauricio and I agree on many things, so that's good to know. Thank you very much for this.
My pleasure, Johan. And it was an amazing pleasure to meet you, to have the opportunity to meet you in person and kind of understand what you work on. Same for Mauricio, mind-boggling what you have as a background behind you. Amazing. So as we love the topic of sustainability, we always talk about this, and we connect. That's the objective, to connect people from different spheres that we can leverage what we all know and have the best projects, have the best results, have the best impact. That's essentially what we aspire to do. So thank you so much for your time, for your presence, for sharing your insights. And for those of you that would like to stay informed on what is happening within the sustainable building realm and sustainable living, you're definitely right at the Frogeex community, where you meet also and hopefully get to know more people like Johan and Mauricio. Amazing. And I see you on the next one. Thank you so much for your time, gentlemen. It was a great
Thank you.
Bravo, Jan.
Good
Thank
to meet
you.
you. Bye.
Please.
Bye-bye. Bye-bye.
Bye.